All right, let's talk about an invisible war that's happening all around us, every single day. It's a war against heat, this relentless force that makes our energy bills skyrocket and can even mess with our food supply. But what if there was a way to outsmart it? Well, today we're going to break down a radical new material that does exactly that.
You know the feeling, right? You open the door to your car after it's been sitting in the sun, and you get hit with that blast of hot air. It's not just annoying, it's actually a massive physics problem. And it all starts with how the sun sends its energy our way, through something called heat radiation.
So just picture the sun beaming out all these waves of energy. Some of them are the light we can see, but a huge chunk of them are these invisible infrared waves that are basically just pure heat. And when those waves hit an object, your car, a window, anything, that object just soaks up the energy and gets hotter. Simple as that, and incredibly powerful.
Now, we've been trying to fight this heat for decades, with films for our windows and coatings for surfaces. But the old ways of doing things, well, they've got some pretty serious flaws. Let's dig into why the traditional approach just isn't cutting it anymore.
For years, we've had two basic plays in the playbook. First, you've got these absorptive films. They act like a sponge for heat, which sounds great, but what happens to a sponge? It gets saturated, and these films get incredibly hot themselves. The other option, reflective films. They basically act like a mirror, just bouncing the heat away. The problem there is you end up blinding your neighbors with glare and adding to light pollution in cities. Neither one is a great solution.
And here's where it gets really weird. Check this out. This test shows a piece of regular glass hitting about 44 degrees Celsius under a heat lamp. But then, look what happens when you put a conventional heat-blocking film on it. The temperature actually jumps up to over 48 degrees. The solution is literally making the surface hotter.
And that's really the heart of the problem with the old way. By trapping all that heat right at the surface, these films can cause materials to degrade, to crack, and they can even start radiating that heat into the building, which completely defeats the purpose. So clearly, a whole new way of thinking was needed.
And that brings us to the breakthrough, a technology developed by Sunzel that doesn't just block heat or bounce it away. It actively and intelligently manages it. This isn't just a small step forward. It's a completely different philosophy when it comes to cooling. So what in the world is intelligent wavelength management? Okay, in simple terms, it's about being super selective. Think of it like a bouncer at a club. It knows exactly which energy waves are the troublemakers, the sun's heat, and it doesn't let them in. But at the same time, it sees the heat that's already inside the building and opens up an express lane for it to get out. It's a one-way street for heat.
And it does this with a brilliant two-step process. First, it selectively blocks the near-infrared waves, or NIR. That's the main type of energy that carries the sun's heat. But here's the magic trick, step 2. It simultaneously turns the surface into a super-efficient radiator. It grabs the object's own internal heat and actively pushes it out as mid-infrared, or MIR, waves, which are the perfect type of energy to travel right through our atmosphere and escape into the cold of deep space. So what does that incredible two-step process actually look like in practice? Well, remember that old film that got dangerously hot, up to 48 degrees Celsius? Under the exact same conditions, the Sunzel film clocked in at just 23.7 degrees. I mean, that is a staggering difference. It's literally cool to the touch. Let's look at the numbers behind that performance, because they're pretty amazing. Compared to older tech, this material is about 25% better at blocking the heat from coming in. That's a nice improvement. But the real game changer is on the other side of the equation. It is 77% more effective at releasing its own heat. That 1-2 punch of blocking and radiating is the secret sauce. Okay, so the science is impressive, the lab tests are mind-blowing, but what does it mean out in the real world? Well, let's look at the proof, because this technology is already being put to the test, and the results are game-changing. The most obvious place to start is our buildings. Just think about the absolutely enormous amount of energy we spend on air conditioning for our homes and offices. If we can manage the heat right at the source, at the windows and on the skin of the building, we can completely rewrite that energy equation. And here is the payoff, 53%. In a real-world test on a commercial building, putting this SunX film on the windows led to a 53% drop in energy used for air conditioning. Let that sink in. That's not a tiny adjustment. That's cutting a building's cooling costs in half. And this table shows us exactly how that happened. So the building with a standard film on it got up to an average of 40.5 degrees Celsius inside. That's just uncomfortably hot. The building with the Sunsec film, a much, much more manageable 32.1 degrees. That's a drop of over 8 degrees just from changing the film on the windows. All right, now let's shift gears from making our offices more comfortable to something even more critical, our food supply. In so many parts of the world, the sun is actually too intense and it makes it impossible to grow certain crops, even in a greenhouse. This technology might just be the answer.
This number is just, well, it's astonishing. A pilot project in Malawi, a place with incredibly powerful sunlight, tested a greenhouse coated with this Sunsex film. The result? It produced 7.5 times the amount of crops compared to what they could grow before. 7.5 times.
And here's the story behind that number. On the left, you've got a standard greenhouse. The temperature inside just soars past 35 degrees, and the plants basically cook. But on the right, you've got the Suncell greenhouse. It stays at a perfect, plant-friendly 28.5 degrees. And get this, as a cool little bonus, the way it filters light also helps keep insect pests away. And the applications just keep rolling in. Think about cars, or even more importantly, emergency shelters. Anywhere that you need cooling without having to plug something in. This is where it can be a matter of safety and survival. I mean, the versatility is just incredible. For cars, tests show it can drop the inside temperature by more than 7 degrees. For an emergency shelter in a disaster zone, that's a literal lifesaver. You can even weave the technology into fabrics to make smarter clothes. And maybe most importantly, this stuff is tough. It has passed all kinds of brutal durability tests, so we know it's a solution that's built to last. So when you put all of these pieces together, it becomes really clear that we're looking at more than just a cool new material. This is a fundamental new tool that has the potential to completely reshape our relationship with the sun and with heat itself. So what are the big takeaways here? First, massive energy savings, which also means a smaller carbon footprint. Second, real improvements in comfort and safety for all of us. Third, and this is huge, a genuine leap forward in food security for some of the most vulnerable parts of the world. And finally, because it's so durable, it's a solution that lasts, which means less waste.
I think this quote just nails it. For so long, when it came to heat, we had two brute force options: absorb it and get hot, or reflect it and create glare. Now we have a third option: finesse. We can actually work with the heat, not just fight it. And that really just leaves us with a fascinating question to ponder. By finally figuring out how to work with the laws of physics instead of against them, we've unlocked this whole new level of control. It really makes you wonder, what other invisible forces are out there just waiting for the next breakthrough? Thanks for joining me.